students. This is Dr. C. Sonia, Assistant Professor in Chemistry, SNS College of Technology. Today in this DT based video, we are going to see about ion exchange resin. Okay, so what is the necessity of seeing about the ion exchange resin? That's the empathy part is you have the water with the minerals. Okay, when there is excess of minerals, it cannot be used for industrial purposes. So it is very important to remove the minerals from the water to use it for any industrial purposes. Can anyone say what are the minerals that is present in the water?
Calcium, magnesium, sodium, chloride, iron, zinc, potassium.
Okay, so you have so many minerals that is present in the water. And what is the cation? What is a cation and what is an anion?
Cation, positive ions, and anion, negative ions.
Yeah, very good. Okay, so the minerals it may be a cation or anion. Okay, it can be removed from the water by the ion exchange process. Okay, so here we have this ion exchange process. Can you tell? Here it is a cation exchange column, anion exchange column, where all the minerals are exchanged and you get the deionized water. Can you tell just overview the full process?
First, the forward is passed to the cation exchange column. Then the cations are removed here. Then it is passed to the anion exchange column. Here anions are removed. Both cations and anions are removed. So the water is known as deionization.
Yeah.
So it is also known as deionization.
Okay, so this process is called demineralized. The water that is coming out is called the demineralized water or deionized water. And the process is called the demineralization process, or you can say it as ion exchange resins. Okay, so I am going to explain what it is. So here you have the exchange resins. Okay, so the ion exchange resins is nothing but it's a cross-linked long chain organic polymers. Okay, and they are microporous in nature, where it will exchange either the cation or the anion. So you have two columns. This is the cation exchange column, and the next is the anion exchange column. So what it is, you have the resin that is COOH, HS23 minus. These are the resins that is present in the cation exchange column. In the anion exchange column, you have the resins like amines, quaternary amines. Okay, quaternary ammonium. All these things will be used as a resin in the anion exchange column. You are first letting in the raw water. Raw water. What is the raw water?
Normal water.
It is a water that is just you are collecting in the reservoir, right? It may have any minerals, it may have any chemical that is present over here. Okay, so any water that is collected in the reservoir, they will be having more of mineral content. Okay, they are sent first to the cation exchange resin. Okay, for example, let us take the water. It has the calcium sulfate and sodium chloride minerals that is present over here. These are the salts that is present in the water. When this is passed through the cation exchange resin, that is the cation is here, which is the cation? Calcium sulfate, Ca, 2 plus is the cation, Na plus is the cation, then sulfate is the 2 minus is the anion, and Cl minus is the anions that is present in the calcium sulfate and sodium chloride. Okay, so what will happen? Here the cations, calcium ion and sodium ion, are being exchanged in this cation exchange resin. Okay, so what is here present in this resin is you have the H plus ions that is present in the resin. When the water is passing through it, the calcium ion is replaced by H plus ion, and also the sodium ion is replaced by the H plus ion present over here. And the water that is coming out, it has only the anion, that is the sulfate and the chloride ion only is present outside, which is coming out, right? Then after that, it is made to pass to the next column, that is the anion exchange column. So this anions, that is the sulfate and the chloride ion, when it is passed to the anion exchange resin, where it is exchanged with OH minus ion. Okay, so this sulfate ion and chloride ion, they are being substituted by the OH minus ion. Okay, and the water that is coming out of this is here it is exchanged with H plus ion, and in the anion exchanger it is exchanged with OH minus ion, and finally you get H2O that is coming out of the water, this chamber. Okay, so you have the water called the demineralized water or deionized water. Okay. So in this process, now you are going on sending the raw water into the ion exchange first. Then after that you get the deionized or demineralized water. When this process is going on, after some time what will happen? These H plus ion and the OH minus ion in the resin, they will get exhausted. Okay, there will be an exchange process and you will have this calcium or sodium salt or any other minerals, okay, over here. And here also sulfate, chloride or any other anions will be deposited over here. At that condition, it's called exhausted. Okay, can any one of you tell what is this exhausted and how you will regenerate in this process?
When we are talking about the regeneration, the cation, when cation exchange resin is exhausted, we can regenerate it through hydrogen chloride. When anion exchange resin is exhausted, we can regenerate through sodium hydroxide.
Okay, very good. See here, I am adding dilute HCl or dilute sulfuric acid will be added to this resin, cation exchange resin, where it will be this H plus ion will be replaced over here, and here you are having dilute sodium hydroxide. When you add, OH minus will be replaced over here. So let us now see the process that is in cation exchange. You have the RH plus, this is the resin. Here the Na plus is the cation. You get R, Na plus H plus. If it is suppose calcium, you get R plus Ca2 plus 2H plus. In the regeneration of this cation exchanger, you have R, Na plus, you are adding HCl or sulfuric acid. Okay, so you get, when it is HCl, H plus ion, you will get again RH plus Na plus. The same, this reactant, that is your resin is regenerated in this process. Okay, in the anion exchange resin, you are having ROH minus, this is the anion, when it is replaced by chloride, RCl minus plus OH minus. Okay, so this ROH minus, when it is sulfate, you get R2SO4 minus plus 2OH minus. This process, the regeneration, what you will get is, so this is your exhausted resin, RCl minus is your exhausted resin. When you add the sodium hydroxide, okay, you will get ROH minus. So this is the regenerated resin plus you will get the chloride ion. Okay, so like this the regeneration of the resin is done. Okay, did you understand this? Can you tell what will be the advantages of these processes?
This process used to treat high acidic or water or alkaline water, and this process also used to produce water with low hardness of 2 ppm, and it is used in high pressure boilers.
Very good. Okay, what will be the disadvantages?
Ma'am, expensive equipments are used in this, and like expensive resins like chemicals are used for this, and when we use iron or magnesium containing water, it cannot be processed through this, as both iron and magnesium get exchanged irreversibly, and the turbid water cannot be treated through this because the turbidity reduces the efficiency of this process.
Yeah. The main disadvantages is the turbidity. If the water is turbid, it cannot be used in this process, ion exchange process. First, the turbidity should be removed. Then after that only you can make the water to get through this process. Okay. And another thing is, if you have heavy metals that is present in the water, suppose, then it is not easy to remove the heavy metals through this process. Okay, so advantages is you will get the demineralized, deionized water. This is the advantage, and the process is not that difficult, right? So this is about the ion exchange resin and demineralization process. Okay, thank you students.
Thank you.